Good evening, Bhavishya. Good evening, Nandana.
Good evening, ma'am. Good evening, ma'am.
Good evening.
Ma'am completed the homework, some ma'am.
Very good. This one, right?
Yes, ma'am.
Very good. Very good. Okay. I don't think this needs any explanation. It's very straightforward, right?
Yes, ma'am.
Yeah. So which box requires lesser amount of material? Lesser amount of material to make. So you have to lesser amount of material to make the box, meaning you should assume that the box is covered all over. The box is covered all over. All the 6 faces are covered with the material. The material may be cardboard, it can be steel, it can be any material, plastic, any material. So we assume that the material is used all over. That is for making all the 6 faces. So we have to find the total surface area of the cuboidal box and the total surface of the total surface area of the cubical box. Okay. So we were talking about this one in the last class. Did we finish writing this?
Yes, ma'am.
Okay, okay. All right. So we'll just see this again. So to cover one suitcase with tarpaulin, this is the amount of material or tarpaulin required. How do you find the area or amount of tarpaulin required? Since you'll have to cover the suitcase all over on the outside, you have to cover the suitcase all over on the outside. All the 6 faces. How do you know it's a cuboidal suitcase? Because the length, breadth, and height is given. See here, length, breadth, and height is given. So it is a cuboidal suitcase. And it has to be covered all over with tarpaulin cloth. So the area of tarpaulin needed to cover one suitcase will be the total surface area. 2 of LB plus BH plus LH, the total surface area. So this is the TSA of one suitcase. So into 100 will be the TSA of 100 suitcases, or the area of tarpaulin required to make 100 suitcases. It is a total surface area because you'll have to cover the suitcase with tarpaulin all over. All the 6 faces have to be covered with tarpaulin on the outside. So total surface area into 100 will be the area of tarpaulin needed to make 100 suitcases. Now, this is the total area of tarpaulin required. But tarpaulin, which is sold in the market, will be available in rectangular form. And to the shopkeeper, you only have to suggest the length. You have to tell him the length of the tarpaulin you need. The breadth is fixed, and that is what is given, 96 centimeters. The breadth is fixed. So when you buy the material, it's going to be like this. This breadth is fixed. There will be a long rod, and the material will be wound around the rod, or sometimes it's folded and kept. Okay, large quantities of material are simply folded and kept. Now this width is fixed. You have to say how much length you need. You should say, give me 1 meter, give me 2 meters, give me 3 meters. You can only say the length of the tarpaulin you need. The breadth is fixed. And that is given to you in the question. In the market, tarpaulin which is available has a width of 96 centimeters. The tarpaulin material which is available in the market has a width of 96 centimeters is given. So if you need so much tarpaulin, that means this is the area of tarpaulin you need to buy. This is the area of tarpaulin you need to buy, and tarpaulin is rectangular. So L into B is equal to this area, and B is given 96. So L is equal to 14,400 centimeters. And since it's a very large value in centimeter, we convert it to meters. So you get 144 meters. So you need to buy 144 meters of tarpaulin, or the length of tarpaulin is 144 meters. Yeah, this is the next one. Find the side of a cube whose surface area is 600 centimeters square. So whenever it is given surface area, it always means total surface area. Surface area. Now you might ask, surface area means curved surface area or total surface area? Because when it's simply surface area, it can be curved surface area or total surface area. But in mathematics, whenever the word surface area is used, it always means total surface area. If nothing is mentioned, it's always total surface area. Or if the object is given, I will see that later. Or it depends. Now here nothing is given. It's just mentioned it's a cube and the word surface area is used. So it's a total surface area. So TSA of the cube, don't write children, TSA of the cube is equal to 600 is given. TSA is equal to 600 is given. What is the formula to find the TSA of a cube? What is the formula to find the TSA of a cube?
6a square.
6a square. 6a square is equal to 600. How do we solve this?
We should bring this 6 into right side.
Yeah, a square is equal to 600 by
6, mom.
6. Because 6 into a square. 6 and a square are in multiplication. So to the other side, it comes for division. So a square is equal to, what is 600 by 6?
100, mom.
100. So what is a? A is equal to?
Mom, a is equal to 10,000.
No.
Square root of 100.
Who's that? Nandana, is it?
Yes, ma'am.
Very good. If a square is 100, a is equal to the square root of 100. A is equal to, what is the square root of 100?
10, ma'am.
10. 10. So the side of the cube is equal to 10 centimeters because it's given in centimeter square. The surface area is given in centimeter square. So side is equal to 10 centimeter. Please write down, children. Write the question and write down the answer.
Completed, mom.
Okay. What about Nandana?
Completed.
Yeah. Okay, the next one. Rukshan painted the outside of the cabinet of measure 1 meter by 2 meters by 1.5 meters. So he paints the outside of a cabinet, and these are the dimensions of the cabinet: length, breadth, and height, all in meters. All in meters. So Rukshar painted the outside of the cabinet of measure 1 meter by 2 meters by 1.5 meters. How much surface area did she cover if she painted all except the bottom of the cabinet? So Rukshar, she painted all over. You can see the cabinet in the figure below. She's painted all over, but not the bottom, except the bottom. So you should find the surface area she's painted. What will be the formula, children? She's painted all over except the bottom. So how will you find the surface area she's painted? Tell me the formula.
Mom, L into B. Ma'am, 2 LB plus BH plus LH. Ma'am, 2 LB plus LH plus BH, ma'am.
Okay, that's all.
LB plus BH plus LH.
Okay, that's all.
Ma'am, square units.
Okay, but children, that is a formula to find the area of all the 6 faces. All 6 faces. That's the total surface area, which is the area of all the 6 faces. This is only 4 plus 1, 5 faces. She's painted all the faces. That is the curved surface area she's painted. She's painted the top. She's not painted the bottom. Please think like that. She's painted the curved surface area, the 4 vertical faces.
Ma'am, only 1 LB she's painting, ma'am.
Yeah, she's painted only 1 LB. So what is she? Think about what she's painted. She's painted 4 curved, the 4 flat, the vertical surfaces, the 4 vertical surfaces. That is the curved surface area she's painted. And then the top she's painted, but she's not painted the bottom. So she's painted only CSA and the top. So what's the formula? What's the formula to find?
Ma'am, 1 LB plus 2 BH plus 2 LH, ma'am.
No, what is the formula to find the curved surface area? 4 faces. Look into your book. What's the formula to find the curved surface area?
4 is square.
That is for a cube, ma. This is a cuboid.
2L plus B into H, ma'am.
2L plus B into H. So when you find the 2L plus B into H, that means you have found the area of 4 faces. Now to this, you should add the area of one more face. That is the top face. What's the area of the top face?
Ma'am, L into B.
LB. That's all. So this is the area of 4 faces. This is the area of the top face. Top face. So when you find this, you find the area of 5 faces, not the bottom. You can do this, or what you should do, this is the total surface area, 2 of LB plus BH plus LH. This is the area of all the 6 faces. From this, you must remove the area of the bottom face, LB. Anything you can do. Do you all understand what is meant by curved surface area?
Yes, ma'am.
Okay, curved surface area is the area of the 4 vertical surfaces. I told you that there are 4 vertical surfaces and 2 horizontal surfaces. Yes or no, children?
Yes, ma'am.
Okay, so what you can do is, see, you should find all the area except the area of the bottom. So what you should do, find the area of all the 6 faces, 2 of LB plus BH plus LH. This is the area of all the 6 faces. But no, she's not painted all the 6 faces. She's not painted the bottom. She's painted only 5 faces. So this is for 6 faces, minus 1 face, minus the area of 1 face. This is the area of 6 faces. No. Take away the area of 1 face. That is, take away L into B. Correct?
Yes.
Yeah. Or else what you can do is you can find the area of 4 faces, which is 2 of L plus B into H. But this is the area of only 4 faces. You need to find the area of 5 faces. So plus the area of the top face, plus the area of 1 face. That is the top face. So plus LB. Both will give you the same result. You can do this one. Instead of doing this, you can do this one. Both are correct. You will get the same answer in both the ways. Please make a note of this, children, that you can find it in these 2 ways. See, anyways, we are finding either do 4 plus 1, 5 or 6 minus 1, 5. Either 6 faces minus 1 face. It's 5 faces, area of 5 faces. Or area of 4 faces plus the area of 1 face, 5 faces. Is it clear, children?
Yes, ma'am.
Okay. Just make a note of this. I'll show you the answer. Done this?
Yes, mom.
Okay. Please take down the answer.
Completed.
Yeah.
Completed, mom.
Yeah. Children, this should be very clear, children. Any questions here? Whatever doubt you have in your mind, please ask. So where all is the cabinet painted, children? Where all is the cabinet painted?
Mom, except the bottom,
All over. How many faces does the cabinet have?
And 6 faces.
6 faces. Now, children, because there are 2 doors, don't get confused. This full thing is 1 face only. This full thing is 1 face. Now, don't think there are 2 doors, so it will be 7 faces. No, this is 1 face. This is only 1 face. Okay. So 5 faces are painted. How can you find the area of 5 faces? Either area of 4 faces plus 1 face plus area of 1 face, or
minus 1 face.
Very good. Or you can find area of all the 6 faces minus the area of 1 face. You should find net, you should find the area of 5 faces. Okay, so what have we done here? Area of 4 faces, that is the curved surface area of the cabinet, plus the area of the top. So here we have not included the area of the bottom. CAC of the cabinet is the area of the 4 surfaces and plus the area of the top. So we have not included the area of the bottom. So CSA is 2H into L plus B and the top is L into B. So while substituting, you need to substitute the values very carefully, children. 2H. H is 1.5. You cannot take any value you please. See, this is L, this is B, this is H. So 2H H is 1.5 into L plus B, 1 plus 2, plus L into B, 1 into 2. You cannot take anything for L, B, and H. Order L, B, H. This is the order, all right? And then how do we simplify? 2 into 1.5 is 3. 1 plus 2 is 3. Plus 1 into 2 is 2. 9 plus 2, 11 meters square. All right, children. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth, and height of 15 meters, 10 meters, and 7 meters, respectively. So, respectively means this order. Length is 15 meters, breadth is 10 meters, and height is 7 meters. That is why this word respectively. You should use the values in the order. First, length, second, breadth, third, height. So, this is length, this is breadth, this is height. That's why this word respectively. From each can of paint. So where all is Daniel painting? He's painting the walls, that is the 4 walls, and the ceiling. Of course, the floor is not painted. The floor is tiled. The floor is not painted. So he's painting the 4 walls and the ceiling. And the dimensions are given. LBH is given to you. Now, from each can of paint is that can of paint. Okay, so from each can, that container can, from each container of paint, 100 meters square of area is painted. So if he takes 1 can of paint, 1 container of paint, he can paint an area of 100 meters square. There's 1 small container of paint. If you use it fully, you would have painted 100 meters square. How many cans of paint will, why she, Daniel, I thought is he, will he need to paint the room? How many cans of paint will he need to paint the room is the question. Now, one second, Chetan. Yeah. Now, supposing, you find the area, okay? So supposing you find the area and the area of 4 walls and the ceiling, okay, plus the ceiling. The area of 4 walls and the ceiling, say, is 900 meters square. 900 meters square. And what is Daniel given? From, if he uses 1 can of paint, from this he can paint 100 meters square area. From another similar can of paint, he can paint another 100 meters square. And using another can of paint, he can paint 100 meters square. So now to paint a total area of 900 meters square, how many cans of paint should he buy?
From 900 meter square cans, ma'am. Then first we should convert 900 meter into meter.
No. It's a very, okay, 1 minute. No, you have not understood.
We should multiply.
No. 1 minute. No. Wait. Let me tell you again. 1 minute. Listen carefully. Now, supposing we find the area of 4 walls and the ceiling plus the area of the ceiling, this total area which is to be painted, area of ceiling. Okay. The total area which is to be painted is 900 meters square. Okay. Now, what has Daniel mentioned? With using 1 can of paint, he can paint an area of 100 meters square. So if he finishes this can of paint, 100 meters square of area is painted. Now, what is the total area to be painted? 900 meters square. And from 1 can, you can paint 100 meters square. So how many cans will you buy from the market? 9. Yeah. If Daniel buys 1 can, he can paint 100 meters square. If Daniel buys 2 cans, okay, he buys another can, he can paint another 100 meters square. That is 200 meters square. If he buys another can, he can paint another 100 meters square. So 300 meters square. So he has to buy 9 cans of paint to paint 900 meter square area. Yes or no, children? So number of cans is equal to area to be painted divided by 100 meters square. Whatever is the area to be painted. So supposing 900 meters square is to be painted, divided by 100 meters square. So 9 cans. Yeah. Do this, children. Done, children?
No, ma'am.
Okay, sorry.
Done, ma'am.
All right. Describe how the two figures are alike. Alike meaning the similarities. Describe how the two figures are alike, the similarities, and how they are different, their differences. So you can see that one object or one figure is a cylinder and the other is a cube. Yeah, it's a cube. The other one is a cube. One is a cylinder, the other is a cube. So you will have to write their similarities and differences. Describe how the two figures are alike and how they are different. Which box has larger lateral surface area? That is the curved surface area. I told you that lateral surface area is nothing but the curved surface area. Curved surface area. Okay. Yes, children? Please write down. This is very direct. So you know lateral surface area for a cylinder is 2 pi RH and for a cube is 4a square. Yeah, I'm sure you can help yourself with this one. Please write down. Done, children?
Then
Very good.
done, ma'am.
All right. So is it clear, children? The two objects, they're alike because both of them are solids. Both of them are solids, so that can be a similarity. And the difference is that cylinder has no corners. Now, supposing you are in a cylindrical room, there is no corner there. You cannot go and stand in any corner. There is no corner. A cylinder has no corners, but a cube has 8 corners. You can see here. Corners. These are the corners. These are the corners. There's one here also, no? There. A cube has 8 corners. Okay, and you have to find which box has the larger curved surface area. So the curved surface area of a cylinder is 2 pi r h, and of a cube is 4a square. And 7 square is 49. 4 into 49, 196. Here, pi, the value of pi is 22 by 7. So 2 into 22 by 7 into r. What is the radius? Radius is not 7. This is the diameter. See here, from here to here is the diameter of the circle. Please watch. What is it from here to here? From here to here is the diameter. That is given to be 7. So the diameter is 7. The diameter is 7. So the radius is 7 by 2. So even if it's a simple question, we may go wrong there. So be careful. 7 is not the radius, it's the diameter, because it is from this end to this end, which is 7 diameter. So half of that, 7 by 2. Into height, you can clearly see here, the height of the cylinder is 7. The height of the cylinder is 7. So radius RH, R is 7 by 2 and H is 7. So how do you simplify this? 7 and 7 cancels, 2 and 2 cancels, 22 into 7 is 154. You should not multiply everything, children. Don't do this. Don't multiply 2 into 22, then into 7 into 7, and then divided by 7 to the 14. Don't multiply the numerators, multiply the denominators, and then divide. That's highly time consuming. You're not supposed to do that. Simplify, cancel the 2 and 2, cancel the 7 and 7. 22 into 7, 154. So it's very clear that the cubical box has a larger lateral surface area than the cylindrical box. A closed cylindrical tank. See there, a closed cylindrical tank. That means it's a tank. So definitely there is CSA in the bottom. Since it's a tank meaning it should hold water, right? So if it should hold water, if it's a tank, definitely there is CSA and definitely the bottom is closed. Yes or no, children? Tank, it's a tank. A cylindrical tank. Yes. If it's a cylindrical tank, then definitely the body, the curved surface area is there. And also the bottom of the tank, the circular bottom of the tank is covered. Is covered because it's a tank. It can't be open, it is covered. Now the question is the top of the tank covered or is it open? Because it's a tank, right? So the top of the tank may be open or closed. Yes or no? Yeah. Yes or no, children?
Yes, ma'am.
Yeah. So we should understand from the word tank. So since it's a tank, the body, the curved surface area is present. That is, there is material used to make the curved surface area, and there is material also used to make the base of the tank, the circular base of the tank. Now the question is, so there is material here. Supposing it's made of steel. There is steel here, and there is steel used here also. Now the question is the top open or closed? If it is open, there is no steel here. There is no steel here if it's open. If it's closed, here also steel is used. So from the words in the question, you must imagine how the tank will be, where all the material will be used. Okay, so a closed cylindrical tank, that means it is covered. The top has a lid. The top is covered. Closed cylindrical tank. That means the cylindrical tank is not open at the top. It is closed. So there is material used all over. See, it's made of metal. So the body is made of metal. This circle is made of metal. And the top is also made of metal because it's a closed one. It's a closed tank. So everywhere there is metal. Metal is in the total surface area of the cylindrical tank. Everywhere there is metal. Curved surface area, area of the bottom, area of the top, everywhere there is metal used because it's a closed tank. Radius is given, height is given. Both are in meters. Both are in meters. So the question is, how much sheet of metal is required? How much sheet of metal is required to make the tank? It's a closed tank. Radius and height is given. It's made from sheet of metal. How much should you buy from the market to build this tank? So you have to find the total surface area. You'll have to find the total surface area because the material will be used all over. The material will be used to make the curved surface area. The material that is the metal. Metal will be used to make the bottom, used to make the top, used to make the curved surface area. Everywhere metal is used. So see here. How much sheet of metal is required? Yeah. 1 minute, children. Yeah, children. Please write down.
Completed.
So area of metal sheet needed is equal to the total surface area, 2 pi r into r plus h square units. Substitute the values and calculate. So here also 7 and 7 will get cancelled. After substituting, 7 and 7 gets cancelled. 2 into 22 is 44. 7 plus 3 is 10. 44 into 10 is 440 meters square. Right on, children?
Done, ma'am.
Please make a note of this, children. Surface area of a closed cylindrical tank is the total surface area. But the surface area of an open cylindrical tank will be CSA plus the area of the base. So 2 pi RH plus pi R square. If it's an open tank, there is no material on the top. So where is the material? The material is there along the CSA. And the base is covered because it's a tank. So the base is covered. So CSA plus area of base. And the base is a circle. So pi R square. Write on this. Okay. Yeah. The lateral surface area of a hollow cylinder. The lateral surface area of a hollow cylinder. When we say hollow cylinder, now just imagine, you tear a paper from your notebook. You tear a paper from your notebook and you just bring the opposite ends together. Okay, you roll it. You roll it and you bring the opposite ends together. Like you roll it and you bring these two ends together. You make them meet. So don't you think you formed a cylinder, a hollow cylinder? You can see through the cylinder. Yes or no? When you tear a small piece of paper, a small piece of paper, just roll it and make these two ends meet. This end and this end meet. Make them meet. And you can see also through it. You can see through it also. So that means there is no material covering the base and the top of the cylinder. It's a hollow cylinder. A hollow cylinder is one which is open at both the ends, like a pipe. Like a pipe. Pipe, I don't mean the tap, okay? Because sometimes people say pipe for a tap. I'm not talking about the tap. I'm saying pipe which is used for plumbing purposes. The pipe which is used for plumbing purposes, like this pipe. Okay, a pipe, is open at both the ends. Is open at both the ends. A pipe is open. This is open. There's no material there. Here also, there's no material. It's open. That plastic or whatever material is used here. Material is used only for the CSA. Material is used only to make the CSA of the pipe. The top and the bottom of the pipe, the cylindrical pipe, that is the top circle and the bottom circle. There is no material used there. It's open. That means you can see through the pipe from one end. You can see through the other end. That is a hollow cylinder where there is no material used to cover the circles on the top and bottom. The lateral surface area, that means a curved surface area of a hollow cylinder, is 4,224 centimeters square. It is cut along its height and formed a rectangular sheet of width 33 centimeters. So it's cut open. If you cut it open and spread it, it will be a rectangle. If you cut open the cylinder and you spread it, you cut it, you use a scissor and you cut it like this, use a scissor and cut it like this. Cut, and open it and spread it. It'll be a paper. It'll be, I'm sorry, it'll be a rectangle of width 33 centimeters. Find the perimeter of the rectangular sheet. Find the perimeter of the rectangular sheet. Children, I'm just getting a call. I'll just get back. I'll show you the answer. Just write and I'll explain. Yeah, please write, children. I'll just attend the call and get back to you. Yeah, thank you, children. I'm back.
Mom.
Yeah. Yes, Bhavishya.
Ma'am, in perimeter, 2L plus B square units, no, ma'am.
Oh, not square units. Sorry. sorry. It's just units. Perimeter is just units. Yeah, you're right.
Ma'am, can you show me the seventh answer? Ma'am, you gave that. Ma'am, you gave that surface area of an open cylindrical tank. That formula, can you show me?
Yeah. This is a tank. This is a pipe. Yeah. This is an open cylindrical tank. That means the base is covered. Please understand. See, when it's a tank, there is material used in the curved surface area, and the material is also used to cover the bottom. The bottom. See, what are the three surfaces in a cylinder? The curved surface area, the area of the circle below, and the area of the circle on the top. Yes or no?
Yes, ma'am.
For a cylinder, you can divide the area into three portions. One is the curved surface area. Then is the area of the top and area of the bottom. When it's a tank, the tank holds water. It's a tank. It holds water. That means there should be the CSA and the bottom. The CSA in the bottom is closed, is covered. So if it's a tank, definitely the CSA and the bottom is made of some material. If it's an open tank, the top is open. If it's a closed tank, the top is closed. But a tank will always have the material in a tank, the material will definitely be used along the CSA and the bottom. It's only, the question is only about the top. Is the top open or closed? If it's an open tank, the top is open. If it's a closed tank, the top is closed. That is, if it's a closed tank, there is material used on the top also, the top circle.
Thank you.
Yeah. Okay. So here, children. So we are given the lateral surface area of the hollow cylinder. Hollow cylinder means when it's a hollow cylinder, as I told you, this is open. This one is open, no material there. This one is also open. The bottom is also open. You can see through. From this end, you can see through this end. Hollow cylinder means the top is open, the bottom is also open. The material is used only along the CSA. The material is used only along the CSA. Okay, now when you can just try this. The cylinder, the cylinder, which is a hollow cylinder, that is, it's open on the top and open at the bottom. If you cut it open, if you cut it like this, you cut it open and you spread it, it will be a rectangle. You cut open and spread it, it will be a rectangle. So the curved surface area of the cylinder is nothing but the area of the rectangular sheet. Because the curved surface area, when you cut it open, the curved surface area only becomes the area of the rectangular sheet. See, when you spread it open, it will become like this. So whatever was the curved surface area now becomes the area of the rectangular sheet, 4224. 4224 was earlier the curved surface area of the cylinder. Now, because you cut open the cylinder and you spread it like this, that area becomes the area of the rectangular sheet of paper or whatever material that is there, rectangular sheet. The hollow cylinder is open. It's open at the bottom, open at the top. When you cut open like this, when you cut it here and spread it, it is a rectangle. The curved surface area of the cylinder becomes the area of the rectangle. So the curved surface area of the cylinder is this one. And that only is the area of the rectangle now. Area of the rectangular sheet is the same thing. So that means L into B, because what is the area of a rectangle? L into B. L into B is equal to 4,224. Now it's given that the breadth of the sheet, rectangular sheet, the breadth of the rectangular sheet is 33. Width means breadth. Width meaning breadth. Breadth. Width meaning breadth of the rectangle is 33 is given. So area means area of the rectangle is L into B, which is 4224. B is 33. So L into 33 is equal to 4224. L is equal to 4224 divided by 33. When you simplify, so you can use the tables of 11 first. 11 threes are 33. 11 threes are 33. 11 threes are 33. Yeah, threes are 33. What's the remainder? 4224. 11. 11 threes are 33. So 9 is the remainder. 2 comes down. 2 comes down. So 11 eights are 88. 88. 4 is the remainder. 4 comes down. 11 fours are 44. 0. So 384 times. 384 times. Again, you can simplify 3 and 384. 3 ones are 3 ones are 3 twos are 3 eights are. Like that, children. So like this, you'll have to cancel. So that cancelling, you know, I cannot show when meaning that I cannot show here. I cannot show that simplification part. I can't show. That's what I explained now. So first you simplify by 11 and then by 3, or first by 3 and then by 11, you get 128. So now you know the length of the rectangular sheet. The breadth of the rectangular sheet is already given. The length we now found, the breadth is already given. So the perimeter, we have to find the perimeter of the rectangular sheet. So perimeter of the rectangular sheet is equal to 2 into L plus B units. So length is 128, breadth is 33. Substitute and find the perimeter. Is it fine, children?
Yes, ma'am.
Nandana?
Yes, ma'am.
Okay. Yeah. A road roller takes 750 complete revolutions to move once over to level a road. So there's a road, and to level the road, you know, to level the road roller takes 750 complete revolutions. Okay, so you can see the road roller is cylindrical. The road roller is cylindrical. A road roller takes 750 complete revolutions to move once over to level a road. Find the area of the road if the diameter of the road roller is 84 centimeters and the length is 1 meter. The road roller is cylindrical. So they've given you the diameter. From that you can find the radius. And the length of the road roller is nothing but the height of the cylinder. The length of the road roller is nothing but the height of the cylinder. Now just imagine, you know, this is the road. Okay, this is the road. This is the road. And this is the road roller. Okay, this is just to explain. Now, leave this figure. Leave this figure. Say this is the road. And this is the cylindrical roller. This is the cylindrical roller. This is the cylindrical roller. Okay, this roller has to roll. Imagine, children, this roller has to roll. This roller has to go 750 complete revolutions to level this road. So it has to roll from here. It has to roll, and come till here to level. From this end to this end, it has to roll. So when it rolls from this end to this end, it makes 750 complete revolutions. Now, in one revolution, the CSA, see, understand that the area of the circular ends will not touch the road. The circular ends of the cylinder will not touch the road. What rolls over the road? Only the curved surface area. The curved surface area of the cylinder will rub and go over the road. The circles on the two ends, they will not come in contact with the road at all. So the area of the cylinder that comes in contact with the road, the area of the cylinder that comes in contact with the road is the curved surface area. Is the curved surface area. So the area covered in one revolution, the area covered in one revolution is the curved surface area of the cylinder. Because when the cylinder rolls, when the cylinder makes one complete revolution, when the cylinder makes one complete revolution, its curved surface area would have rubbed the road completely. Its curved surface area would have gone on the road completely. So the area covered in one revolution is equal to the curved surface area of the cylinder. Remember the ends of the cylinder, the circular ends of the cylinder, they don't touch the road at all. It is only the CSA that rubs and goes over the road. So the area of the road, area leveled, okay, area leveled in one revolution is equal to the CSA of the road roller, CSA of the road roller. Area leveled in one revolution is the CSA of the road roller. Now it takes 750 revolutions to level the road. The road roller has to go 750 times, 750 revolutions. So in one revolution, this is the area. So in 750 revolutions, what will be the area? 750 into CSA. I'll write it in simple words. One revolution, CSA. 750 revolutions, 750 into CSA. In one revolution, so in one revolution, area covered is the curved surface area. In 750 revolutions, the area covered will be 750 into CSA. One revolution is CSA. 750 revolutions will be 750 into CSA. And that will be the area of the road. Area of the road. This area from here to here, the area of the road. That will be the area of the road. Now, what is very important is, children, you have to convert. You will have to have both the values in the same unit. You can see here that the diameter is given in centimeter, but the length or the height of the cylinder is given in meter. So you can see here, diameter is cylindrical road roller. Diameter is 84 centimeters. Radius is, so if diameter is 84, radius is 42. 84 divided by 2, 42 centimeters. Height is 1 meter, which is nothing but 100 centimeters. 1 meter, which is 100 centimeters. So while substituting in the formula, we will use R is 42 centimeters and H is 100 centimeters. Both should be in centimeters, or both of them should be in meters. Any one. I have converted meter to centimeter, the bigger unit to the smaller unit. Number of revolutions is 750. So the area of the road is equal to the CSA of the roller into number of revolutions. You can remember this as a formula. The area of the road is equal to the CSA of the roller into the number of revolutions. What is the CSA of the roller? 2 pi RH into the number of revolutions, 750. So 2 into pi is 22 by 7. Radius is 42. Height is 100 into 750. You need to simplify. How do we simplify? 7 ones are 7 6 are 42, and then multiply. So you get so many centimeters square, and you can convert this to meter square because it's a big value. No, you can convert it to meter square. So how do you convert centimeter to meter? Centimeter to meter, you should divide by 100. To convert centimeter square to meter square, do that 2 times. Whatever you do it 2 times. So see here, centimeter square to meter square. Centimeter to meter, divide by 100. Centimeter square to meter square, do it 2 times. 100 into 100. That is divide by 100 2 times. So you should write in the denominator 2 times 100. 100 into 100. So 0, 0, 1, 4 zeros, and 4 zeros get cancelled. So 1980 meter square. So the area of the road is 1980 meter square. So you can remember this is a formula, children. Area of the road is equal to, since only the CSA of the roller will roll over the road, It is a CSA of the roller into the number of revolutions. Right on, children?
Completed.
Yeah.
Completed, ma'am.
All right. So what you have to be careful about here is that the radius is in centimeter. Diameter is 84. So half of 84 is the radius, 42 centimeter, because 84 centimeters or 42 centimeter. But the length, which is the height of the cylinder, the length which is given here is the height of the cylinder. The height of the cylinder is 1 meter. But while substituting, you cannot substitute radius in centimeter and height in meters. You will have to substitute all the values in the formula in the same unit. So we convert meter to centimeter. 1 meter is 100 centimeter. And so we substitute radius in centimeter, 42 centimeter, and height also in centimeter, 100 centimeter. So the answer you get will be in centimeter square area, and convert that to meter square. Yes, Chidu. So I have to tell you something about this. Now, very simple this is. Now, see here, there is a cylindrical container. All right, there's a cylindrical container. There is a cylindrical container. Now, just imagine that you are using paper to cover the CSA of the cylinder. You're using paper to cover the CSA of the cylinder. CSA meaning you're not covering the top circle and the bottom circle. You're covering only the curved portion, the curved surface area of the cylinder. So the area of the paper will be equal to 2 pi RH. Because the paper is going around the cylinder. Whatever is the area of the cylinder will be the area of the paper also. You're using paper to cover the CSA. You're sticking paper to cover the CSA of the cylinder. So what will be the area of paper you need? Whatever is the CSA of the cylinder, curved surface area. Supposing the curved surface area of the cylinder is 50 centimeters square. So then the amount of paper you need to cover the CSA will also be 50 centimeters square. Now, supposing you're not covering the CSA completely, you know how you're going to cover? You're going to cover it like this. Like what? Okay, now supposing the height of the cylinder is say 10 meters. You're 10 centimeters. You're leaving 1 centimeter on the top. You're leaving 1 centimeter on the top. You're also leaving 1 centimeter in the bottom. 1 centimeter at the bottom. So you're covering only this part of the cylinder, this part of the curved surface area of the cylinder. This one, okay, like this. Please imagine that. So you're using a strip of paper. You're using a strip of paper and you're covering the CSA of the cylinder. You're leaving 1 centimeter of the cylinder on top and 1 centimeter of the cylinder below, not covered with paper. You're not covering that with paper. On the top and bottom, you're leaving 1 centimeter length. You're not covering that portion. So now supposing the radius of the cylinder is 7 centimeters. The radius of the cylinder is 7 centimeters. The area of paper you need is 2 pi RH because you are going to cover the paper all along the CSA and the CSA of the cylinder is 2 pi RH. So how much paper you will need? 2 pi RH. Now, what's the value of pi? 22 by 7. What's the value of R? I've given 7. R is 7. The value of H will not be 10. Instead, it will only be 10 minus 2, 8. Because you're not covering the total height. You're not covering this entire height of 10 centimeters. You're leaving 1 centimeter on the top and 1 centimeter below. So the height of the cylinder which you should take will be 10 minus 1 minus 1. So 10 minus 2, 8 centimeters. So this will be the area of paper you need. So first, what we need to understand is when you're covering the curved surface area of the cylinder with paper, the area of paper you need will be equal to the curved surface area of the cylinder. That's the first thing. But if you're not covering the curved surface area completely, you are leaving 1 centimeter on the top and 1 centimeter below. Then the area of the paper needed will be 2 pi RH. But when you substitute the value of H, you should reduce. So like from the total height of 10 centimeters, we reduce 2 centimeters. Sometimes what you have to do, no? Now you have a cylinder, you have a cylinder like this. You have a cylinder like this. You have to cover it with paper. But say you have to tuck inside. You'll have to tuck inside some 2 centimeters here and 2 centimeters here. The total height is 10 centimeters. The total height is 10 centimeters. You have to cover up. You'll have to cover up the curved surface area of the cylinder with paper. But you're not covering it exactly. You're tucking in some paper. You're putting the paper inside and sticking it in the inside. You're covering the CSA with paper, but you need more length because you're going to put it inside. You're going to wrap it all over and tuck it inside. That inside, you're tucking to a height of 2 centimeter. So from top and bottom, you'll tuck it inside. Say from top 2 centimeter, from bottom 2 centimeter, you're tucking it. Then the height of the paper you need, or the height of the cylinder will be 10 plus 2 plus 2, 14 centimeters. Say the radius is 7 centimeters. So the area of paper you need will be equal to the curved surface area of the cylinder, which is 2 pi RH. Okay, so 2 into 22 by 7 into radius is 7. It's not diameter, so this is the radius only. So 7 into height will be this total height 10, and that extra you need to tuck inside. You need extra no to tuck inside and tuck inside from the top and bottom. So you should add the 10 plus 2 plus 2. 14 will be the height. This will be the area of paper. You calculate this. This will be the area of paper needed. So there are three cases. There are three cases. First case is when you're covering the CSA. The first case is when you're covering the CSA, like supposing radius is 7, height is 10, and you're just sticking paper, along the CSA. Nothing extra. Nothing extra. Along the CSA, you're sticking paper. So then the area of paper needed is 2 pi RH, where R is 7 and H is 10. That is 2 into 22 by 7 into R is 7 and H is 10. Now, like in this case, what you see above, like here, what's happening? What's happening here? From the top and bottom, they're leaving 2 centimeters. Top 2 centimeters and bottom 2 centimeters. So the area of paper needed will be 2 pi RH, 2 pi RH, but it's 2 into 22 by 7. Radius is 7 because diameter you can see is 14. So radius is 7 into height will be like in this case. In this case, the height will be, the total height is 20, but 2 centimeters less here. So 20 minus
20 minus 2 minus.
Yeah, minus 2 minus 2. So it will be 16. And the third case is when you're tucking inside. So that is, you're covering this full height with paper and you have to go inside and tuck. You'll have to go inside the cylinder and tuck from the top and bottom. And supposing tucking is 2 centimeters on the top you tuck and 2 centimeters from bottom you tuck. Then the area of paper you need will be equal to the CSA, which is 2 pi RH. And it will be 2 into 22 by 7 into R, radius. Radius is 14 by 2, 7. You can see here, diameter is 14. So radius is 7 into height will be 20 plus 2 plus 2, 24. Height will be 24. So simply alter the height, that's all. Either you subtract or you add, or you take the same height, depending on the situation. Now you can understand this. Yeah, please write. I think I've explained, children. You can understand. Please write down the answer. Read the question. I did not read the question for you. Please read the question, understand the question, and then start working.
Then we can find the radius by dividing the diameter.
Yeah. Yeah, diameter is 14 centimeters because it's marked there. End to end is 14. So radius will be 14 by 2, 7 centimeters. You can take the answer like this, children. 1 minute. Let me write it here for you. Please write down this. -20 minus 2 minus 2, 16.
Done, ma'am.
Yeah. So radius is 14 by 2, 7. And the height is not 20. 20 minus 2 minus 2, 16. Okay, now you can understand this. So here I've just mentioned the the values for the cylinder and the label. So cylinder, the radius is 7 and height is 20. For the cylinder, height is 20. But the label also goes around the cylinder. So the label also, after sticking it, it will be cylindrical. Once you stick the label, the label also will be cylindrical. So the radius is 7 centimeters. Height of the label will be 20 minus 4, 16. That's what I've written here. Once you stick the label along the CSA of the cylinder, the label also will be cylindrical. So the radius of the label will be the radius of the cylinder, 7. And the height of the label will be whatever is the height of the cylinder minus 4, 16. So what I've written here is area of the label. Area of the label is equal to CSA of the cylinder, 2 pi RH. So 2 into 22 by 7 into R, 7 into H, 16. Done, children? Did you write the question? Are you both writing the question, or since you have NCERT maths textbook, you're just writing the reference number?
No, ma'am, I'm writing the question only.
Yeah, that's only easy when you're referring, you can, when the answer is along with the question, it's easy to revise. Otherwise, you'll have to keep your textbook on one side, see the question there, and then see the answer inside the book. So 2 books you'll have to keep, one for the question, the other for the answer. It's always good to write the question and then work the answer. It's easy while revising. You finished writing, children?
Yes, ma'am.
Okay. They are different, so I thought I can give some homework, but no. All right, children. All right, children. That's it for today's session. We started at. I started the class, I think, at 7:05.
Yes, ma'am.
I'd posted the timings to 7 to 8:30. Harshita, when did you join the class?
Ma'am, 7:50, ma'am.
7:50, huh?
Yes, ma'am.
Oh, you had Hindi class.
Yes, ma'am.
Okay, fine. All right. So will it be useful, Harshita, if but I don't know for the others. 8 to 9:30 will be good for you, is it, Harshita?
Ma'am, yes, ma'am. Ma'am, but I do have other homework, ma'am. So I don't know.
What?
Class, I'll try joining earlier, ma'am.
Okay. No, but that might become too late for the others. Maybe it will become too late for dinner. All right, we'll see in a class where everybody is there. Maybe if I have to change the timings, I can do, but we need to check with the others. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Yes, ma'am. Thank you, ma'am.
Thank you.
Thank you.